Hi everyone. Hello, welcome to this mathematics session. In this session, I will start a new lesson, determinants. Determinant was first introduced by a famous German mathematician, Carl Gauss. Then it is developed to find a solution for the system of linear equations in n variables. You know, the system of linear equations in two variables can be written as 2x plus 3y is equal to 8, x plus y is equal to 3. Okay, these are the system of linear the two equations with the two variables, linear equation in two variables x and y. So similarly, to find a solution for the system of linear equations in 3, 4, 5 up to n variables, we can use determinants. Also, it has wide applications and uses. It is used to find the area of triangle. It is used to find the equation of the plane in three-dimensional system or in the space. It is also used to find the inverse of a square matrix. First, whether the inverse exists, and then find it. Also, it is used to find in the coding theory. That is, in the wireless system, to design the space-time codes, determinants can be used. So, it has a wide applications in physics, mechanics, social science, economics, etc. Now, for your board examination till now, around 12 marks were allotted for this lesson. In the board examination 2020 March examination, one question each of 1 mark, 2 marks, 4 marks and 5 marks were asked from determinant. So, it is a quite important lesson. Now, what is a determinant? To understand determinant, recall what is a matrix and what is a square matrix. Okay. So, matrix is just an arrangement of numbers or functions in the rows and columns within the bracket. It is an arrangement of numbers or functions, or we can say it is an ordered rectangular array of numbers or functions. Okay. So, for example, A is a matrix with elements 2, 3, 4, 5 means, you know, it has two rows, vertical lines are called columns, horizontal lines are called as rows. So, it has two rows, R1 first row, R2 second row, and it has two columns, C1, C2. So, its order we can write it as 2 cross 2 or 2 by 2. So, since the number of rows and number of columns are equal, so we can say that it is a square matrix. A square matrix is a matrix in which the number of rows is equal to number of columns. Here look at this, 2 rows and 2 columns it has. So, simply we can write its order is 2. Order of this matrix A is 2. It has 2 rows and 2 columns. Look at this, B is a matrix. Here the elements are -1, 0, cos alpha, 5, -4, 2. Look at this matrix. It has 2 rows, horizontal lines are called as rows, and 3 columns, 3 vertical lines it has. So, its order is 2 cross 3. Here the number of rows and number of columns are not equal. The number of rows is 2, number of columns is 3. So, it is not a square matrix, it is a rectangular matrix. Now, look at this. If the number of rows of a matrix is equal to the number of columns, it is called as a square matrix. So, A is a square matrix. This is a square matrix with order 2. Now, each square matrix can be associated with some number. A number can be a real or complex. That number is called as determinant. So, one square matrix can be associated with some number, maybe real or complex. Here real, any square matrix can be associated with a number, either real or complex. That number is called as the determinant of a square matrix. So, determinant is a number associated to the square matrix. Okay. Here A is a square matrix, number of rows and number of columns are equal to 2. So, a number can be associated to it, that is called as it's the determinant of a square matrix A. So, A is a square matrix and the determinant of A is denoted by, look at this, how to read this? Determinant A between the two vertical bars. If you write A, it is known as determinant A. So, it is not modulus of A, you should not read it as modulus, it is determinant. Okay, determinant of A. Also, we name it as det A, determinant of A, or we can simply write delta. It is also named as delta. So, a number, real or complex, can be associated to every square matrix. That number is called as the determinant of A. All right. So, this determinant value, a number, is unique. So, it can be either real or complex, but that number is unique. For every square matrix, there is a unique number which is associated with that is known as the determinant of that square matrix. So, now we can define the determinant of a square matrix. So, how can you define? Every square matrix A is equal to Aij. Look at this. Every matrix can be denoted by A is equal to Aij of order n. Here square matrix can be denoted by if A is equal to Aij. I represent the number of row, J represent the column, the number of column. So, it is any one element of a matrix A. Aij is a random element of a matrix A, and any square matrix can be written as A is equal to Aij, matrix Aij of order n. So, every square matrix A is equal to Aij of order n is associated with the number, this number can be real or complex, which is called the determinant of a square matrix A. Please make a note of this. Every square matrix A is equal to Aij, one square matrix, can be associated with a unique number. That number is called a determinant, is called the determinant of that square matrix A. So, determinant can be denoted by determinant A in this way, det A or determinant A, or delta. It is denoted by determinant A, which is also determinant A, can be written as like this, det A, or simply delta, denoted in this way. Determinant is denoted by determinant A, delta, or simply determinant A. If A is a square matrix with elements 1, 2, 3, 4, now its determinant is denoted by determinant A, and determinant value, when you write the determinant A, you have to write the numbers within the vertical bars, that is 1, 2, 3, 4. So, if A is a square matrix, the elements are 1, 2, 3, 4, that implies determinant A can be written as 1, 2, 3, 4 this way, or it is also denoted by det A or simply delta. Different ways we can express. Now, this determinant can also be used as a function also. You can say determinant is a function, because you know function f is a function from x to y, if you write such that f of x is equal to y, you generally define like this. Now, f is a function, determinant is also a function, so we can write it as determinant is a function from, what is here, x is a domain, y is a codomain. So, x is a domain here. For determinant, the domain is the set of all square matrices. The set of square matrices, set of all square matrices that is its domain, and 2, the codomain, here the codomain is real or complex number, real or complex. So, if the input is a set of all matrix, if any square matrix, if an input is a square matrix, then output is a number. That is how we can define determinant as a function such that determinant of A is a square matrix here, determinant value of A square matrix is equal to K, where A is a square matrix, A belongs to a square matrix, K belongs to a real or complex number. So, this is how determinant is a function from the set of all square matrices to the number real or complex such that determinant of A is equal to K, where A is a square matrix and K is any number, real or complex number. So, you know, a square matrix has a unique value associated with that, it is called as a determinant, and if you write it as a determinant A, it is read as determinant A, not a modulus of A, it is determinant A. So, in this chapter you are going to learn the determinant of a square matrix of order 1, 2 and 3 of real entries only. So, now you will learn how to find the value of the determinant of a square matrix of order 1, 2 and 3. So, the first one, determinant of a square matrix of order 1. Look at this, let A is equal to, we generally name it as A, is a matrix of order 1, matrix of order 1. If order 1 means it has one row and one column, means it has only one element. So, then the determinant of A is equal to, it has only one number, A is a number, so we write A. A is an element, so we write the same element as determinant A. For example, if A is a square matrix with one element 9, suppose an element is 9. Now, that implies what is the value of determinant A? Determinant A is equal to, as it has only one element, that is 9. So, 9 itself is a answer for determinant. Determinant A is 9. So, it is to find the value of the determinant of a square matrix of order 1. As you know, square matrix of order 1 has only one element. So, determinant value is the same element, that number 9 is a value. Okay. Now, the second one, determinant of a square matrix of order 2. Okay. So, let us consider a square matrix A of order 2. Let A is equal to a square matrix, we generally represent the square matrix as Aij of order 2, is a square matrix of order 2. Now, let us consider A is equal to, we write this as, order 2 means it has 2 rows and 2 columns. So, the elements can be written as A, B, C, D. Suppose the elements are written like this, its order is 2, 2 cross 2, isn't it? Now, what is the value of the determinant of A? Then, determinant of A is written as, the same elements are written within the vertical bars A, B, C, D. So, it is determinant of this square matrix. Now, what is the value of this? How to find the value of this? Look at this. Since it has 2 rows and 2 columns, cross multiply, that is multiply the diagonal elements A into D. So, we write it as AD minus multiply the off diagonal elements, these two, C into B, AD minus CB. So, how to find the determinant value? Multiply the diagonal elements A into D minus multiply the off diagonal elements, other two elements are called as off diagonal elements. So, multiply the off diagonal elements C into B. So, it is the value of the determinant of square matrix of order 2. So, first multiply. So, delta or determinant A or delta is equal to, how do we get this? It is a product of diagonal elements minus the product of diagonal elements, the product of diagonal elements. So, delta can be found, determinant A can be found using multiplying the cross multiplication, it is also known as cross multiplication, A into D minus C into B. So, that is how we can find the determinant value of the square matrix of order 2. Now, let us see a few examples. Evaluate determinant of 2, 4, minus 1, 2. Okay, we have to find the value of the determinant of this. So, determinant delta, let us consider delta is equal to 2, 4, minus 1, 2, determinant value. Now, cross multiplication, as you know, multiply the, therefore, the delta value is multiply the diagonal elements, that is 2 into 2 minus multiply the off diagonal elements minus 1 into 4, minus 1 into 4, which can be written as 4 minus of minus 4 plus 4 is equal to 8. So, delta is equal to 8. Very simple, students. Just multiply the diagonal elements 2 into 2, 4 minus the product of off diagonal elements minus 1 into 4, that is minus of minus 4, they change to plus 4 is equal to 8. Okay, look at the next example. Evaluate determinant of cos theta minus sin theta cos theta. So, let us consider delta is equal to cos theta minus sin theta cos theta. Okay. Now, how to find the value of this? Which is equal to delta is cross multiply cos theta into cos theta, diagonal elements when you multiply it is cos theta into cos theta cos square theta minus the product of off diagonal elements sin theta into minus sin theta. What is that? Minus sin square theta. Already there is minus sign, minus of minus sin square theta is plus sin square theta. Yes, all of you know what is cos square theta plus sin square theta. Yes, sin square theta plus cos square theta is 1. So, the value of the determinant is 1 here. Look at the third question. Evaluate determinant of x plus 1, x minus 1 x. So, it is written as, let us take delta is equal to x plus 1, x minus 1 x as it is. Now, as you know, product of diagonal elements minus the product of diagonal elements, that means delta is equal to x into x, you know, x square minus x minus 1 into x plus 1, x minus 1 into x plus 1, as you know, x minus 1 into x plus 1 is x square minus 1 square, a plus b into a minus b is a square minus b square. So, it is x square minus 1 square, x square minus 1, which can be written as delta is equal to x square minus minus of minus plus 1. So, that x square and x square cancelled. So, we write delta is equal to 1, delta is equal to 1. So, we just have to multiply the diagonal elements minus other two elements, get the value of the delta. Look at the fourth example. Evaluate x square minus x plus 1, x minus 1, determinant value of x plus 1 and x plus 1. So, let us take delta is equal to x square minus x plus 1, x minus 1, x plus 1, x plus 1. And all of you know a minus b into a plus b. Also, we write a square minus b square. Okay. Let us expand this. Therefore, delta is equal to cross multiply, it is x plus 1 into x square minus x plus 1. So, a cube plus b cube is how much? A plus b into a square minus ab plus b square. So, x plus 1 into x square minus x plus 1 is x cube plus 1 cube minus, multiply this, x plus 1 into x minus 1, we know x square minus 1 square, a square minus b square. So, It can be written as x cube minus 1 x cube plus 1 cube minus here x square minus of minus 1 is plus 1. X plus 1 into x minus 1 is x square minus 1. X square minus x plus 1 into x plus 1 is x plus 1 into x square minus x plus 1 is x cube plus 1 cube minus x square plus 1. So, what is this? X cube minus x square plus 2 is the answer. Multiply the diagonal elements x plus 1 into x square minus x plus 1 minus of diagonal elements x plus 1 into x minus 1 is x square minus 1. So, open the bracket, x plus 1 into x square minus x plus 1 is x cube plus 1 cube minus x square minus of minus plus 1. So, it is x cube minus x square plus 2. Okay. Look at the next one, evaluate determinant of 2, 4, minus 5, minus 1. Let delta is equal to 2, 4, minus 5, minus 1. So, delta is cross multiply 2 into minus 1 is minus 2 minus 5 into 4 is minus 20. So, which is minus 2 minus of minus, that is plus 20, is delta is equal to 18. Delta is equal to 18. Please make a note of this. Determinant of a square matrix of order 3. Next one, third one, to find the determinant of a square matrix of order 3. Okay, so let us consider a square matrix. A is equal to a square matrix Aij of order 3 cross 3. Let A be a square matrix of order 3. Now, we can write in general the determinant of A as determinant of A is equal to, you know, order 3 means it has 3 rows and 3 columns. So, R1, R2, R3 are the 3 rows, C1, C2, C3 are the 3 columns. So, the determinant can be written as, the first element is A, which is in the first row and first column. So, it is written as A11. Second one, here A, the element is in the first row and second column. So, first row, second column. Look at this, how to denote the elements. A12 means 1 represent the number of row, 2 represent the column. So, A12. Third one, A13. First row, third column. It is in the first row, third column. And second row elements are such that second row, first column, A21. Second row, second column, A22. Second row, third column, A23. Finally, third row elements are A31, third row, first column, A32, A33. Okay, it is a determinant of a square matrix of order 3. Now, how to find the value of the determinant of a square matrix of order 3? Now, look at this. It has 3 rows and 3 columns, and it can be expanded to find the value of the determinant in 6 ways, that is 3 rows, along 3 rows and 3 columns we can expand it. So, first we will see how to expand it along the first row. Expanding along row 1, first row R1. Look at this, first element here, the first row elements are A11, A12, A13. We are expanding along this. If the determinant is of order 2, we know how to expand it. Previously we have learnt it, that is multiplying the diagonal elements minus the product of off diagonal elements. Now, we reduce this determinant of order 3 to the determinant of a square matrix of order 2. Okay. So, then we know how to expand it. Using the elements of first row, we reduce this into the smaller determinant, that is, so this determinant A is equal to, we can write this as, first element is A11, alright. Now, since the number of row and number of column here are 1 and 1, we write minus 1 raised to the power 1 plus 1. Look at this, minus 1 to the power 1 plus 1, which gives you the sign whether it is positive or negative, A11, into, we write the determinant of, here the determinant of the square matrix of order 2. We reduce it into smaller determinant so that we can how to expand it and find the value of this determinant. So, how do you get the smaller determinant? Delete the first row and first column where this element A11 lies. Where does this element lie here? A11 is in the first row and first column. Eliminate that. What are the 4 elements left? Write it as a determinant. What are the elements left? A22, A23, A32, A33. Look at this. So, how did you get this smaller determinant? Deleting the row and column where this in which A11 lies. So, A11 is in the first row and first column. Eliminate those two. We get that smaller determinant A22, A23, A32, A33. Write it as a determinant. Plus the second element is in the first row, second element is A12. Now, we have to write what is the sign of this, minus 1 raised to the power 1 plus 2 is a position. It gives you the sign whether it is plus A12 or minus A12. So, minus 1 to the power odd number is minus, minus 1 to the power even number is plus, as you know, and the determinant of. Now, eliminate the first row and second column. Where is this A12? A12 is in first row and second column. Eliminate that. What are the 4 elements so formed? A21, A23, isn't it? A31, A33, A31, A33. So, eliminate the first row and second column. Where is this A12? A12 is in the first row and second column. When you delete that, what are the elements remaining? Remaining elements are A21, A23, A31, A33. Write it as a determinant. Now, plus third element in the first row is A13. A13. Now, its sign is minus 1 raised to the power 1 plus 3. 1 plus 3 is 4, minus 1 to the power even number is plus. So, it is plus 1 A13. Now, determinant of. Now, A13 is in the first row and third column. Eliminate first row and third column. What do we get? A21, A22, A21, A22. Remaining elements are A31, A32, A31, A32. Look at this. A13, third element of first row is A13. It is in the first row and third column. Eliminate first row and third column. Delete that. What are the remaining elements? A21, A22, A31, A32. Write it as a determinant. Now, it is what the value of determinant delta or determinant A is. Minus 1 raised to the power 1 plus 1 is 2. You know, minus 1 to the power even number is plus 1, minus 1 to the power odd number is equal to minus 1. So, if you get the sum of the two numbers as even, you have to write it as plus 1 because minus 1 to the power 2, that is minus 1 into minus 1, minus of minus turns to plus. So, it is plus 1, minus 1 to the power odd number, minus 1 to the power 3, minus 1 into minus 1 into minus 1, it turns to minus 1. So, here we have minus 1 to the power 2. So, it is plus A11 into. Here the determinant is a first square matrix 2 of order 2. So, it is possible to cross multiply and find the cross multiply A22, A33 minus product of other two elements A23, A32. Here plus minus 1 to the power 1 plus 2. What is 1 plus 2? 3. Minus 1 to the power 3. Odd number is minus. Minus A12 into. Now, look at this. It is a determinant of order of a square matrix of order 2. So, cross multiply A21, A33 minus A23, A31. Now, minus 1 to the power 1 plus 3, 4 even number. So, you have to write plus 1 into A13, cross multiply here A21, A32 minus A22, A31. Multiply these two, A22 into A31. So, this is the value of the delta or determinant A. So, determinant A is A11 into A22 A33 minus A23 A32 minus A12 into, delete the row and column where A12 is, A21 A33 minus A31 A23 plus A13 into, delete the row and column where A13 is, A21 A32 minus A31 A22. So, this is the value of determinant A. See, here we got the determinant A, value of the determinant A expanding along first row. You can even expand it along the second row, expanding along the third row, or you can expand it along the first column, second column or third column. In any row, along any row or any column, if you expand, you get the same value of the determinant. The value of the determinant is unique always. You can expand it along any row or any column, but the value of the determinant is always same. Here the determinant A will be same always whenever you expand it along any row or any column. Okay. So, let us see a few examples. It is a general form of determinant we have taken. Some examples we will see, and always expand the determinant along a row or column which has a maximum number of zeros, because 0 into some determinant value we will get if you expand it along a row which has maximum zeros. So, it is easy for the calculation. Look at the example. If A is equal to a matrix, A is a matrix, square matrix of order 3, 1, 1, minus 2, 2, 1, minus 3, 5, 4, minus 9, find the determinant A. See, look at the pattern you have to follow. We can follow the pattern to write the sign, symbols plus or minus, follow the pattern. For the determinants, first element is A11. You get the sign of the first A11 when you apply minus 1 raised to the power 1 plus 1. It is 1 plus 1 2, even number means it is always plus, positive sign. So, A11 is plus in sign. So, A12, A13, A21, A22, A23, A31, A32, A33. So, what are the sign? The pattern of the signs of different elements we will see here. A12, add this 1 and 2, it is 3. If you get odd number, it is minus. So, this is minus. Now, the third one, A13, 1 plus 3, 4, 4 is even number. So, it is plus. So, plus, minus, plus. First row elements are plus, minus, plus. The position signs are given as plus, minus, plus. Second row, look at this, 2 plus 1, A21 means 2 plus 1 is 3. Odd number, so minus, 2 plus 2 even number, plus 2 plus 3 5 odd number, minus. So, 3 plus 1 even number, plus 3 plus 2 5 odd number, minus 3 plus 3 6 even number, plus. So, we can follow the pattern in such a way that first row elements are plus, minus, plus. Second row minus, plus, minus. Third row plus, minus, plus. You can observe that diagonally, both the diagonals, the elements are positive and other 4 elements are negative. You can remember this pattern, students. Diagonally, the elements are positive. Here plus, here also positive. All the diagonal elements are positive. The position signs are positive. Other 4 elements are negative. Minus, 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 minus. So, this way you remember the pattern so easily we can expand any determinant. So, consider this solution. Let determinant A is equal to, write it as a determinant. It is 1, 1 minus 2, 2, 1 minus 3, 5, 4 minus 9. It's given like this. So, the elements are 1, 1 minus 2, 2, 1 minus 3, 5, 4 minus 9. Now, we can expand it along any row or any column, we get the same answer. So, let us expand it along the first row. First row elements are 1, 1 minus 2. So, first write the position signs of it. As we know, first row elements are plus, minus, plus, diagonally positive, other 4 are negative in sign. So, above that number we write the position sign plus. Here also, here we have minus sign, for minus 2 it is plus. We can write like this. So, first write the position sign of this as plus, minus, plus, diagonally positive. So, this 2, minus 2 and 1 come along the diagonal. So, this is minus. Now, expanding along first row, expanding along first row R1. R1 is first row, R1. So, we write the position sign first, that implies determinant A is equal to, determinant A value is, first you write the first element 1, then what you need to do? Eliminate the row and column where this 1 dies. So, first row and first column when you eliminate, the remaining elements are 1 minus 3, 4 minus 9. 4 elements you note down, 1 minus 3, 4 minus 9. Now, go to the next element. The sign is minus, the number is 1 into determinant of. Delete the first row and second column. What are the 4 elements remaining? 2 minus 3, 5 minus 9. Since 1 is in the first row, second column, delete that. First row and second column when you delete, 2 minus 3, 5 minus 9. Next number is, position sign is plus, the number is minus 2 into determinant of. Delete the first row and third column where this minus 2 is. Minus 2 is in the first row and third column. Deleting that, the 4 numbers are 2, 1, remaining elements are 2, 1, 5, 4. Now, just expand it, you know that this is a determinant of a square matrix of order 2. How to expand it? We know that determinant A equals 1 into cross multiply minus 9 minus of 4 into minus 3 is minus 12, minus of minus 12 is plus 12, minus 1 into multiply this 2 into minus 9 minus 18, minus 5 into minus 3 is minus 15, minus of minus plus 15. Plus into minus, minus 2 into cross multiply 2 into 4, 8 minus 5 into 1, 5. So, how much is this? So, the value of determinant A is here minus 9 plus 12, 3 minus 1 into minus 18 plus 15 is minus 3 minus 2 into 3. So, it is, how much is it? 3 plus 3 minus 6 is equal to 0. So, the value of the determinant A here is 0. Therefore, determinant A is equal to 0. Its answer is 0. So, it is obtained by expanding along R1. It is possible to expand it along any row or any column, we will see next. We will get the same answer as 0. For this determinant A, the value of determinant is always unique and its value is 0 here. So, first write the position sign here. How to find the determinant of A of a square matrix of order 3? First write the position sign plus, minus, plus for the first row. We are expanding along R1, we have written. Now, first write plus 1. Delete the row and column where 1 is. 1 is in the first row, first column. Delete it. 4 numbers we have. Write it as a determinant 1 minus 3, 4 minus 9. The next one, the position sign is minus. The number is 1, minus 1 we write. The elements in the first row we have to observe. Minus 1. Now delete the first row and the second column. Where is this 1 in the first row, second column? Delete that. What are the elements? 2, minus 3, 5, minus 9. Write it as a determinant. Next number is minus 2, position sign is plus, plus minus 2. It is in the first row, third column. Delete that. First row, second column. What are the 4 elements? 2, 1, 5, 4. Write it as a determinant. Now, just the expansion of a determinant of smaller order, that is order 2 here. So, determinant A is 1 into cross multiply minus 9 minus of 4 into minus 3 plus 12 minus 1 into 5 into minus 9 minus 18 minus 5 into minus 3, that is minus 15. So, minus of minus turns to plus 15 minus 2 into 8 minus 5. So, 3 plus 3 minus 6 is 0. Evaluate, the determinant value is given. Determinant is 2, the numbers are 2 minus 2 minus 2, minus 1 minus 2, 0, 2 minus 1, 3 minus 5, 0. Look at this. Let us consider it as delta. Delta is equal to 2 minus 1 minus 2, 0, 2 minus 1, 3 minus 5, 0. Okay. Now, always it is better to expand along a row or column which has maximum zeros. Here in the first column you can see 1 0. It is possible to expand it along the first column. Expanding, we will expand it along first column now. Expanding along first column. What are the elements of first column? 2, 0, 3. Now we know its position signs are diagonally positive, other elements are negative. So, diagonally 2 is positive, then 0 is minus, 3 is plus. Diagonally, that is plus minus plus, minus plus minus, plus minus plus. So, these elements are positive, other 4 are negative. So, here in the first column the position signs are plus minus plus, plus minus plus we have written. Now, expanding along the first column, we can write delta is equal to, first column elements are 2, 0 and 3. So, first write plus 2, its sign is plus, so plus 2 into 2 is in the first row and first column. Delete that, delete the first row and first column. What are the 4 elements so obtained? 2, write it as 2 minus 1 minus 5, 0. So, these 4 elements are obtained, write it as a determinant. Now, the second element here in the first column, the second element is 0 and here the position is minus 0. 0 into any determinant will turn to 0 only, no need to write the determinant, minus 0 is enough. Now, plus third element is, the sign is plus, the number is 3. 3 into determinant, 3 is in the first column and third row first column. Delete the first column and third row. What are the 4 elements so formed? Third row and first column when you delete. The elements, remaining elements are minus 1, minus 2, 2, minus 1. Minus 1, minus 2, 2, minus 1. Now, that is what the third element, we have written the determinant also. So, delta is equal to, look at this, 2 into cross multiply 2 minus 2 into 0 0 minus 5 into minus 1 is plus 5. So, 0 minus 5 plus 3 into cross multiply minus 1 1 minus 2 into minus 2 is minus 4, minus of minus plus 4. So, the value of delta is equal to 2 into minus 5 minus 10, 5 into 3 plus 15. So, what is delta? Delta is equal to 5. Delta is equal to 5 is the answer. This is how did you expand this? Here we have expanded it along the first column. We got the value as 5. Is it possible to expand it along the any row or any column, like third column, third row? Suppose we expand it along the third row. Here also we will have 1 0, isn't it? In the third row you will get 1 0. So, let us expand it along the third row. We have to get the same answer, as delta value will be unique. Therefore, we have to get 5 itself. Let us see, expand the same question in the along the third row. Look at this. let delta is equal to, what do we have? 2 minus 1 minus 2, 0, 2 minus 1, 3 minus 5, 0. Now expand it along the third row. Expanding along third row, third row. Here third row elements are 3 minus 5, 0. Okay. So as we know, the signs can, the position sign can be written as, for the first one 3 it is plus, then minus, plus. This is plus, it is minus, it is plus. Plus minus plus. Now expanding it, delta is equal to, first number is 3, so it is position sign is plus, so plus 3 into determinant of 3 is in the third row and first column, delete third row and first column. Remaining elements minus 1, minus 2, 2, minus 1. Okay. Now we are expanding along the third row. So first element is 3, 3 is in the third row and first column, we have deleted. So we got the determinant minus 1, minus 2, 2, minus 1. Next element is minus 5, its position sign is minus. So minus of minus 5, look at this, how to write, minus of minus 5 into, this minus 5 is in the third row and second column. Delete the third row and second column. What are the 4 elements? 2, minus 2, 0, minus 1 are the 4 elements. Third row, second column elements are deleted, remaining 2, minus 2, 0, minus 1. Now what is the third element? Third element in the third row is 0. 0 into any determinant is 0 only. So no need to write that. That implies delta is equal to 3 into, cross multiply, minus 1 into minus 1, 1 minus 2 into minus 2, minus 4, so it is plus 4. Minus of minus, plus 5 into, cross multiply, 2 into minus 1 is minus 2, minus 0 into any term is 0. So what is the value? Delta is equal to 5 into 3, 15, minus 5 into minus 2, plus 5 into minus 2 is minus 10, implies delta is equal to 5. Okay. We have expanded the same delta determinant along third row and we got the same answer as 5. Here we have expanded along the first column, we got the answer as 5. So here we got to know that if we expand the determinant along any row or any column, the value of the determinant is same, is delta is equal to 5 here we got. Thank you.